Climate change as we know today is being caused by an abrupt change in the Earth's temperature. In the last 650,000 years, there have been 7 cycles of glacial advance and retreat, with the abrupt end of the last ice age about 11,700 years ago. Most of these climate changes are attributed to very small variations of Earth's orbit that change the amount of solar energy our planet receives. The current warming trend is significant because most of it is extremely likely to be the result of human activity. In the graph, it can be inferred that the unprecedented warming trend saw a spike post-industrial revolution and has been climbing ever since. In the last 13 years, we have seen 10 of the hottest years on record. This warming trend has been observable since the mid-20th century, likely due to human activity exacerbating the greenhouse effect on Earth. The greenhouse effect overall is a good thing. It warms the planet to its comfortable average temperature of 59 degrees Fahrenheit, 15 degrees Celsius, and keeps life on Earth viable. Without it, the world would be a frozen, uninhabitable place, more like Mars. The problem is, mankind's burning of fossil fuels for energy is artificially amping up the natural greenhouse effect. This leads to an increase in global warming that is altering the planet's climate systems in countless ways. The main gases responsible for the greenhouse effect include carbon dioxide, methane, nitrous oxide, and water vapor, which all occur naturally, and fluorinated gases, which are synthetic. The most abundant and longest lasting of all greenhouse gases is carbon dioxide. Of all the man-made emissions of carbon dioxide from 1750 to 2010, approximately half were generated in the last 40 years alone, in large part due to the fossil fuel combustion industrial processes. And while global greenhouse gas emissions have occasionally dropped from year to year, most recently between 2014 and 2016, they are accelerating once again. In 2017, carbon emissions rose by 1.6%. In 2018, they increased by an estimated 2.7%. Carbon dioxide accounts for about 76% of global human-caused emissions. Once it's emitted into the atmosphere, 40% still remains after 100 years, 20% after 1,000 years, and 10% as long as 10,000 years later. For methane, even though it persists in the atmosphere for far less time than carbon dioxide, it is much more potent in terms of the greenhouse effect. Globally, it accounts for approximately 16% of human-generated greenhouse gas emissions. Nitrous oxide is a powerful greenhouse gas. It remains in the atmosphere on average a little more than a century. It accounts for about 6% of human-caused greenhouse gas emissions worldwide. Although fluorinated gases are emitted in smaller quantities than other greenhouse gases, they account for just 2% of man-made global greenhouse gas emissions. They trap substantially more heat. Indeed, they have long atmospheric lifetimes, in some cases lasting tens to thousands of years. The most abundant greenhouse gas overall, water vapor, differs from other greenhouse gases in that changes in its atmospheric concentrations are linked not to human activities directly, but rather to the warming that results from the other greenhouse gases we emit. Warmer air holds more water, and since water vapor is a greenhouse gas, more water absorbs more heat, inducing even greater warming and perpetuating a positive feedback loop. It's worth noting, however, that the net impact of this feedback loop is still uncertain, as increased water vapor also increases cloud cover that reflects the sun's energy away from the Earth. The increase in greenhouse gases, which leads to an increase in higher temperatures on Earth, is the main factor in determining the impacts of climate change on humans and nature. One of the major impacts will be an increase in sea levels across the world. The two major causes of global sea level rise are thermal expansion, caused by the warming of the ocean, and increased melting of land-based ice, such as glaciers and ice sheets. With continued ocean and atmospheric warming, sea levels will likely rise for many centuries at rates higher than that of the current century. In the United States, almost 40% of the population lives in relatively high population density coastal areas, where sea level plays a role in flooding, shoreline erosion, and hazards from storms. Globally, 8 of the world's 10 largest cities are near a coast, according to the UN Atlas of the Oceans. Increases in sea levels also attribute to the increases in nuisance flooding across the globe. Climate change is also making weather patterns more severe and destructive. Surrounding the areas of increased ocean temperatures, storms, such as hurricanes and monsoons, are trending upwards in categories and frequency. This is seen most effectively in the 2020 hurricane season, where hurricanes are substantially more frequent and destructive. In areas that are experiencing long-term droughts brought on by climate change, there is an increase in fires and the destructiveness of those fires. Since the beginning of the Industrial Revolution, these organizations have failed to address the full cost of their production and instead have pushed these costs to the market wherever possible. Basically, the carbon prices do not equate to the climate change costs that their products cause. This means that these markets do not account for the negative externalities present in the markets. A negative externality is defined as a cost that is suffered by a third party as a result of an economic transaction. For fossil fuels, this includes everything from the negative impacts of habitat destruction and the acquiring of raw materials, to the cost of cleaning up from natural disasters worsened by climate change. Since greenhouse gas emissions from fossil fuels are the major contributor to climate change, it could be argued that all damage due to climate change is a negative externality of the fossil fuel industry. The best way to change these negative externalities and market failures is to balance costs by making sure that fossil fuels, or any energy resource, are accurately represented in the markets.
Okay, now let's take a look at climate change in an economic viewpoint. Why economics? Because they're the ones that help us understand where the money goes. While the chemists and the climatologists can help us what's going on in the atmosphere with climate change, the economists are going to help us understand how it works between corporations and people and governments and what it's really going to look like in our everyday lives. So let's go back to Econ 101, supply and demand, right? That's what we learned in high school about economics. And we also learned the first fundamental theorem of welfare economics, which tells us certain markets will reach an efficient allocation. Boom. And that's where we found the efficient allocation to be, where supply equals demand. But this is only in certain markets, which have perfect information, everything is tradable and has a price, and there's perfect competition, which doesn't happen in every market. So let's revisit our supply and demand curve, which is now relabeled to be the marginal benefits and the marginal costs. And let's look at an example for how this actually plays out in a place like Carson, California, which is just south of Los Angeles near Long Beach. And this oil refinery takes crude oil and converts it into gasoline that we use every day. And they produce a certain amount as long as there is a demand for it. And if the demand changes, then they will move to a more efficient solution and maybe produce less gasoline. But this is not a perfect market. One of those markets where those three criteria I listed off are met, right? Because there are other things going on outside of that market that impact people, like smog. Right? The oil refinery produces carbon dioxide and other particulate matter that gets into the air, hangs out around the ground, and helps our kids get asthma, makes the elderly have to stay indoors, cancels our soccer games. Kind of looks like there's another wildfire going on in California, except there isn't. It's just smog, right? And wildfires related to climate change, but we aren't going to talk about that. Okay. So this was before where we had our efficient solution, but now our marginal costs have changed to be the social marginal costs, where all the negative effects that happen outside of that market are taken account for. And so now with the social marginal costs in play, we've created some inefficiencies in our market like deadweight loss. Some of the total welfare before is now negative. And once we reach a new efficient solution, all those deadweight loss and the negative welfare get taken away, and the actual total welfare in the system has increased. And this is good because consumers and producers like it when there's lots of welfare. Okay, so the refinery is still able to produce oil. Consumers are still able to consume oil. It just happens at a lower quantity and a slightly higher price. And maybe we can enjoy more sunsets that look like this. But how do we get the market to take all these social costs into account? Right? Someone has to do this. And so in the next part of the video, we are going to explore taxes and quotas and different policy solutions to where how we can actually get the markets to reach these more efficient allocations and give us more beautiful sunsets.
Now, there is a high potential for a substantial effect on the U.S. economy if there's no effort to mitigate the effects of climate change. Some of these impacts include loss of agricultural productivity, increase in mortality, crime, energy use, storm activity, and coastal inundation. Now, there are many projections on the economic cost of climate change, and although they may vary slightly in their methodology and results, most conclude that there will be a substantial economic effect if climate change is left unchecked. For example, in 2008, the NRDC, the Natural Resource Defense Council, projected that the total cost of climate change can cost up to 3.6% of the US's annual GDP. By 2100, hurricane damage, real estate losses, energy costs, and water costs will go up to 1.8% of the US's GDP annually, which amounts to $1.9 trillion per year, trillion with a T. Federal agencies also track losses due to climate-related disasters. They've calculated that in the past 5 years, which does not include the record-breaking 2020 disasters, the U.S. alone has experienced more than $500 billion in losses directly linked to climate-fueled weather disasters. Not only is the U.S. expected to experience massive economic losses, the rest of the world will bear the bulk of the economic damage, which will then have indirect effects on the United States because of trade, mitigation, or even conflict. Most studies say the same thing. There will be a massive cost associated with climate-related disasters if we continue down the path we're on. And despite this, there have not been widespread policies enacted in the United States that have been successful in reducing greenhouse gas emissions that lead to climate change. There are environmental policies that could attempt to address the impending climate disaster and economic damage. There are traditional command and control policies that are typically associated with environmental protection. So standards set by, let's say, the Clean Air Act or the Clean Water Act are typically command and control regulatory policies. While command and control legislation has resulted in better environmental practices, it does have its drawbacks. Many are critical of command and control style regulation. They have been critiqued that they're too rigid, inefficient, focus on compliance and punishment, and they're far more reactive than proactive to any issue that may arise. These types of policies have created this adversarial type process where industry is fighting the government. Environmental policy experts and economists alike believe that a market-based approach to climate change policy will be essential if we are to make strides with climate mitigation. I say that market policy should be the primary motive when enacting policy. We've already seen newer approaches to environmental policy have good outcomes. The sulfur dioxide allowance trading program, as a part of the 1990 Clean Air Act amendment, was the world's first large-scale pollutant cap and trade system. And these cap and trade schemes can be viewed as a more cost-effective method as it allows firms to reach environmental compliance by choosing the less expensive option. They can reduce emissions or buy more allowances. However, the U.S. has not enacted a cap and trade style policy for carbon emissions. In fact, most policy proposed to mitigate climate change involves proper pricing of carbon emissions. For example, the private cost of energy generation does not account for the social cost of the emissions associated with that energy. Take energy generation by using coal, as seen in the graph shown. It has the lowest private cost, but it has the highest proportion of social costs to private costs compared to other forms of energy generation. Policymakers view pricing carbon at its full private and social costs as a means to reduce the usage of polluting energy sources and promote less polluting energy sources. So that would be wind or solar. And although wind and solar energy may come with a higher upfront private cost, it has a far smaller associated social cost. And then if these polluting energy sources are accurately priced, then renewable energy will be able to compete and eventually have a larger hold in the energy generation market. Ultimately, much of the focus in our current policy is how to make less polluting energy sources more economically competitive. While there are a few federal level policies directly tackling climate change, there are options at the state level to encourage renewable energy generation through market-based incentives. Renewable portfolio standards are set by state governments, which require a certain amount of the state's energy mix to come from renewable sources such as solar or wind. States can also create tax incentives that encourage the growth of the renewable energy industry within their state. The appeal of market-based policy approach is that it allows for individualization in approach based on geography or local government, while also supporting emerging industries. While there may be some opposition to these policies initially, they are designed in a way to reduce the extensive long-term financial burden